Hello everyone, I'm Professor Ken Wakchore. In this video lecture, we'll study the gear tooth profile. There are two types of gear tooth profiles. One is the involute gear tooth profile and second one is the cyclone gear tooth profile. Both the gear tooth profiles having their own advantages and disadvantages. In this lecture, we'll study both the gear tooth profiles in detail. In the involute gear tooth profile, we have already studied the gear tooth profile, in which how to generate that involute gear tooth profile that we'll study. What we have to do, you have to just wound the string along the circle, which may be, in case of gear tooth profile, this is the pitch circle. So this is the base circle. We have to wound that circle around the base circle, and we have to unwound that by taking that one end or by tracing the end of that string. When we trace that end of that string, we generate one profile which is called as the involute tooth or involute profile. In the gears, we have to consider one base circle and we have to wound that string on that base circle. We have to unwound that. We can find the generated profile, which is the involute profile. Okay. The advantages of the involute profile or how it comes. For that, we have to refer that cross belt drive. In the cross belt drive, we will consider any one point on that belt which always move along this belt. That point B, which is always move along this belt, and that this line which is tangent to this circle and which is again tangent to this circle. That means same concept we have to use in the gear tooth profile or in the conjugate action of this gear tooth profile. That point P, we have to design that tooth profile in a such a way that that point B must be every time must be along the point of contact in case of gear tooth profile. Okay, and this condition gets satisfied in the involute gear tooth profile and the cyclone gear tooth profile. That's why we have to use these two gear tooth profiles in the gears to have the uniform velocity ratio. Okay, again, in case of involute gear tooth profile, in case of if we change the center distance between two gear tooth profile, it do not affect the velocity ratio. That means up to the certain limit, if we increase the center distance between these two gears, this is the O2 is the center of this one gear and O3 is the center of the second gear or the counterpart. If we increase this distance between these two gears up to the certain limit, it do not affect their velocity ratio. Okay. Second, pressure angle remains constant. This is again very important, that pressure angle must be same throughout the operation to have the uniform velocity ratio, and which remains constant in case of involute tooth profile. Again, straight teeth of the basic rack in the for involute admits the simple tool. That means in case of manufacturing the gear tooth profile, because of its simple that straight teeth on the rack, which makes the that manufacture of this gear tooth profile, which makes the simple and the cheap. Okay. Second one is the cyclone tooth profile. In the cyclone tooth profile, now here in the earlier case in the involute tooth profile we have to consider the base circle, and in case of cyclone tooth profile we have to consider the pitch circle. Just try to understand. If you allow to rotate, now we have considered one base circle, one pitch circle. On that pitch circle we have considered one circle which allows to rotate on the pitch or above the pitch circle without slipping. We are just rotating this circle above the pitch circle without rotating, which traces one curve. This contact point or this point, when I allow to rotate, which moves to the next position and subsequently traces one curve. This is called as the epicycloidal curve. Again, in the same way, same circle you have to consider inside of this pitch circle. Again, we have to allow to rotate without slipping, which traces the second curve, which is the hypocycloidal curve. That means in case of cycloid tooth profile, there are two types of gear tooth profile, two curves. One is the epicycloidal and second one is the hypocycloidal. Again, same curve we can generate on the rack. In this case, you have to just consider one horizontal line. Again, on that line, you have to just rotate one circle without slipping, which traces one curve, which is the epicycloidal, and below the line in the opposite direction, which traces again second curve, which is the hypocycloidal. That means cycloidal curve in the gears, which is the combination of two gear tooth profiles. One is the epicycloidal and second one is the hypocycloidal. The profile above the pitch circle, which is called as the epicycloidal, and profile below the pitch circle, which is referred as a hypocycloidal. Here you will find epicycloidal, hypocycloidal. Okay. At cycloid teeth, cycloid gears which do not have the interference. What is mean of interference, that we'll discuss in the next part of this course. But this is very important. There is no interference in the cycloid gear tooth profile. Again, cycloid tooth are very strong as compared to the involute gear tooth profiles. Next, because of spreading flank, they have the high strength and compact drives are achievable with the help of the cycloid gear tooth profile. Cycloid teeth have the longer life and low wear as compared to the involute gear tooth profile. Disadvantages of the cycloid gear tooth profile: if we change the center distance, or because of wear out, if there is a sudden change in the center distance, we never obtain the uniform velocity ratio as that of the involute gear tooth profile. In the involute gear tooth profile, up to the certain limit, if we change the center distance, still we will get the uniform velocity ratio. The hub of the cycloid gear has the curved teeth, unlike the involute. That means while preparing while manufacturing the cycloid gear, that tool we require the complex tool. And in case of involute gear tooth profile, we have the straight edge profile. That means to manufacture the cycloid gear tooth profile, which is very costly affair, again costly and the difficult. Okay, next one is the applications. Cycloid gears are extensively used in the watches, instruments, where the strength and the interference are prime considerations. Next, again in case of heavy machinery, paper mill, sugar mills, you will find the application of the cycloid gear tooth profile. Again, if we consider the involute gear tooth profile, all our gearboxes and the gears which consist of the involute gear tooth profile. The difference between the involute gear tooth profile and the cycloid tooth profile: in the involute gear tooth profile, the pressure angles remain same throughout the operation, but in case of cycloid tooth profile, at the start and at the end of the contact gear, that pressure angle changes. That's why you'll find sudden jerk at the start and at the end. Next, teeth are weaker. Yes, that because of the flank, which is the narrow, and in case of cycloid teeth, which is the broad, that's why the teeth are stronger as compared to the involute gear tooth profile. Again, this is easy to manufacture. Involute gear tooth profiles are easy to manufacture, but cycloid gear tooth profile, which are difficult to manufacture because it consists of the two curves. One is the epicycloidal and second one is the hypocycloidal. The velocity is not affected due to the variation in the center distance that we already studied. If we change the center distance between the two gears up to the certain limit, that velocity ratio remains same, but same condition which is not applicable for the cycloid gear tooth profile. If we change the center distance, velocity ratio may get changed. Again, in case of involute gear tooth profile, interference takes place. In case of cycloid tooth profile, there is no any interference. Again, more wear and tear at contact takes place between the contact surfaces in case of involute gear tooth profile, and you will find the less wear and tear in case of cyclone gear tooth profile. If you consider the cost, involute gear takes the, that means we can manufacture in the less cost as compared to the cyclone gear tooth profile. Okay, in this way we have studied the involute and the cyclone gear tooth profile. Thank you.